So lesson 3 I wrote here, characteristics of lines. Before, what we're going to start to do, Kenzie, is we're going to start to learn a shortcut for how to graph a line just by glancing at it. But to do that, you have to rearrange the line so it looks, the equation, so it looks a certain way. So to do that, Katie, we're going to do a quick review of some basic equation solving rules. Okay? In fact, when you're solving equations, there's 2 rules. So I wrote down here, from the previous unit on functions, we often preferred to write equations with the y variable by itself. In fact, on my graphing calculator, if I want to graph, I have to get the y by itself. It won't graph anything if I don't get the y by itself. So this skill you'll use next year and the year after in your math as well. However, not all equations are written with the y already by itself. So we're going to be using equation solving, and remember, there are 2 rules in equation solving. Rule 1, do the opposite of what is being done to the variable. Say what? If they're plussing 5 to x, you know what you should do? Minus 5. If they're timesing the y by 3, you know what you should do? Divide by 3. If they're dividing the y by 9, you know what you should do? If they're squaring the y, what's the opposite of squaring, of a squared? Square root. If they're cubing, cube root. In fact, almost every single mathematical operation out there has its opposite. Fancy word, its inverse. The operation that undoes it. The only one that doesn't is timesing by 0. Can you times by 0? Yep. Can you divide by 0? Nope. So it's one of the ones that has no backward. Almost all of them do. The second rule is this. Do the same thing to both sides. Looking at what's being done to the variable tells you what mathematical operation to do, the opposite. And then please remember, you got to do it to both sides. I had a math teacher, colleague of mine, he gives his kids an acronym, because the question a lot of students have is, hey, what order do I do all this stuff? I wish I'd come up with this because I think it's brilliant. You can write it up here. The acronym that he uses is the word felt sad. Because if you do it wrong, you'll felt sad. Okay. You can write that down in capital letters vertically. If you're wondering, because what if more than one thing is being done to the x? What do you do first? Here's the order of operations for equation solving, not BEDMAS. In fact, it's reverse BEDMAS. The first thing that you deal with is you clear any fractions. That's what the F stands for, Brendan, which I can see you're writing this down. Graham, the next thing you do is you expand any brackets. Get rid of brackets, but G doesn't work as well as E for expand in this little acronym. The L and the T go together. They're 2 words. Gather what? Okay? So after you've gotten rid of any fractions, Curtis, after you've gotten rid of any brackets, expand. Then what you do, look for any like terms. The S and the A go together. Then you do any of your subtracting and adding. The very last thing you do, which is what kids want to do first, which is the habit I need to break you of, the very last thing you do any dividing that's necessary. If you do it wrong, you'll felt sad. If you do it right, you won't felt sad. Example 1, I wrote down here, solve. Okay. In example 1, seest thou any fractions? Do you see any fractions? Check. Expand. Any brackets to get rid of? Check. And then what does the LT stand for? What I mean by like terms is on the same side of the equal side. So take a look at this. I know there is more than one x, but is there more than one x on the same side of the equal sign? No. Is there more than one constant term on the same side of the equal sign? No. No like terms together. Now we do our adding and subtracting. And the strategy here was you wanted to get all of the x's to the same side. How could I get all of the x's to the same side? Well, I got to be fussy. Technically, okay. We're not gathering like terms. We want to get all the x's. Maybe you were right. I cut you off. Say it again. Go ahead. I wouldn't do that yet. I would get all the x's to one side first. I deal with numbers last. Get your x's to the same side first. Trust me. I would add 20x to both sides. Or you could minus 16x to both sides. There's nothing wrong with that. But anytime I can get rid of negatives, I'll choose to do that. And Carmelina, that's why I would have dealt with the x's first, because it lets me get rid of a negative x, and that's when I'm more likely to make a dumb mistake. I've learned over the years. Get my x's to one side first. So, Logan, hints for equation solving. Okay? Equation solving is very methodical, but because each of these involves multiple steps, there's plenty of room to make mistakes. I'm going to try and give you some hints. First of all, I would write here, add 20x, add 20x. And do you notice I kept my x's in line with each other? I would do that. And here is trick of the trade, Mr. Dewick's dumb hint number 1. Rachel, if you discipline yourself, once you've drawn that line, the first thing you do after that is not write anything. The first thing is drop your equal sign down and keep it in line. For some reason, if I can beat that into my grade 9 students, keeping the equal signs in line and dropping that down, Nicole, that gets rid of a lot of their dumb mistakes. I don't know why. Maybe it gives them a reference point, but I saw the silly mistakes go way down. So my advice to you, keep your equal signs in line. And in fact, anytime you move to a new line, drop the equal sign down first thing, because now you can clearly see what's on what side. Oh, and I notice, right? The 13 drops down like a domino. On the left-hand side, Ty, I have 16x plus 20x. That's a 36x. The negative 5 drops down like a domino. Now what? What side is the x on? The left side or the right side? Left, so I'm going to move stuff from the left over to the right. I'm still in my felt sad approach. I'm still in the A and S subtracting and adding things. What do I want to do now? I want to add 5. Come on, pen. I'm going to drop my equal sign down, keeping them in line. I get 18. Yay! I get 36. Now what? Sorry? Divide by 36. And when I do that, I'll get x equals 18 over 36, but that reduces. Oh, that's 1 over 2. I was going to divide by 9, but I can go actually divide by 18. If you divided by 9, you'd get 4 over 8. Sorry, if you divided by, yeah, you get, you'd get 2 over 4. You'd clue in that you could go further. Anyways, it is 1 over 2. You don't have to, but I always, with a little feeling of pride, like to put a box around my answer saying, waha, ta-da, there it is. In grade 12, I actually teach my kids, we write, which is Latin for quo ertas demonstrandum, which means which was to be demonstrated. You do that at the end of a proof. But here, we'll just put a box. B, fractions. Expand, brackets. I'll get rid of those. I'll get 6x minus 12 equals 8x plus 10. Graham, I want you to notice something. Once I got rid of the brackets, I now have, look up, variable number, variable number. Isn't it now exactly like A, where that had a variable number, a variable, and a number? Our strategy for equation solving, Ty, is whenever possible, we turn it into one we already know how to solve. So, now what? I would not minus 8x. It's not wrong. I would not minus 8x. You know why? Because that's going to give me a negative 2x over here, and I suck with negatives. Instead, I'm going to choose to minus 6x. Why? Because I make less dumb mistakes that way. And I like my students to get used to working on either side of the equation. Now, you may have had a Math 9 teacher who told you, always move stuff to the left side. I say, no. Sometimes it's way easier to move stuff to the right than do it. Jake? Yes? Drop my equal sign down, keeping him in line. The negative 12 drops down like a domino. And then I have 8x take away 6x, which I'm also more likely to get right than 6x take away 8x. I mean, I'll probably get that one right too, Nate, but you know, I've learned as a test, anytime I can avoid the stupid mistakes that my brain makes tripping on itself, I try and avoid those. Oh, and the plus 10 drops down like a domino. What side is the x on this time? The right side. All right, so let's get it by itself. How? So minus 10, do the opposite. I notice we're plusing 10. Let's minus 10. The equal sign drops down. I get on the left side negative 12, take away 10 more. Negative 22, yes? If you're not sure, you could use your calculator, but... Oh, woohoo! The 2x drops down like a domino. Now what? Divide what? Because the most common mistake, kids are so used to the x being on the left, I see kids divide both sides by negative 22. Is that what you want to do? Where is the x? On the right-hand side. What are you trying to get by itself? The x. What's in front of it? A 2. So divide by 2, divide by 2, and you get x equals negative 11. Oh, by the way, what if this hadn't worked out evenly? Curtis, what if instead of negative 22 over 2, what if it had been negative 22 over 5? Leave it as a fraction, not as a decimal, and leave it as a fraction in lowest terms. Especially if it's something like this. Can you, on your calculators, all of you right now, go negative 22 divided by 19? Yep, hang on, I got to clear. Get out of this. Sorry, what? No, it's not. Actually, this is a repeating decimal. Except instead of the repeating decimal being just one digit long, like 0.33333333, or 2 digits long, like 0.161616. We've seen those, yes. This repeating decimal is 18 digits long, which means there's no way you would have known that if I hadn't told you that, which means you would be tempted to round off somewhere, and you're wrong. Oh, if you leave it as a fraction, negative 22 over 19, is there any doubt whatsoever? Is there any rounding off? Do we have to ask any questions like that? So, Carmelina, if it doesn't work out evenly, in math, leave it as a fraction. What about in science when you find slope? There they prefer the decimal values. Yes, thank you. C. C. Fractions? Brackets? Expand? Okay, let's get rid of those. Most common mistake, look up. This one drives me crazy. Rachel, look up. Kenzie, most common mistake I see is this one. Kids go, oh, this is 2 minus 5, that's a 3. How can you be subtracting before you've taken care of brackets? It's not a 3. It is going to be a multiply, 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 multiply. What number is right here after the negative before the bracket? There's an invisible 1, multiply, multiply. And it's going to look like this. The 2 drops down like a domino. I have a negative 15. I have a positive 5x. I have a positive 4x. I have a positive 2. Drop my equal sign down. The 3 drops down like a domino. I have a negative 1x. I'm not going to write the 1. I have a positive 2, and then the positive 4 drops down like a domino. Ta-da! I've gotten rid of brackets. Now what? LT. There are more than one x on each side in some situations, and certainly more than one constant in each side. So I'm going to gather like terms. On the left-hand side, how many x's do I really have grand total? 9 x's. What about constants numbers? I have 2 take away 15 plus 2. See it? 2 take away 15 is negative 13 plus 2. Is it negative 11, I think? Yes? Katie, do you remember what I said was a simple, dumb way to get rid of dumb mistakes? Keep what in line with itself? So even though I've got a big space, I'll do that. On the right-hand side, how many x's do I have grand total? I got to be careful, technically not 1. Okay, negative x, I'll drop that down. And then I'll gather up the like terms for the numbers. I see a positive 3 plus 2 plus 4. I can do that in my head, I think. 3 plus 2, Brendan, is what? Plus 4? And positive or negative? By saying that in my mind, it reminds me to put a positive, not put a plus sign there, right? Brendan, look, 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 look. Do you see that we now have, look, 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 letter, number, variable, number? You mean once again we've turned it into question 1a? There's our goal. So, solve this on your own. I shall solve it up here. Let's see if we get the same thing. I think I'd start by plussing x to both sides. Yes? Same as me? Over 1, I wouldn't freak out, but you can't make me write extra stuff that I don't need to. Right. Thumbs up. Next page. Fractions, the math F word, not the F word you're thinking of. Actually, fractions in equations aren't a big deal at all because, Sarah, there's a great trick, a great useful skill. On the first line, you can make fractions go away completely. You can get rid of them totally. How do I do that, you ask? How do I do that, you ask? I'm so glad you asked. It's actually a really simple little trick. What you do is you clear the fractions by multiplying everything by a common denominator. Say what? First of all, take a look at this example. Fractions? Yes. What's my common denominator? Which would work. By the way, the nice thing about this trick, it doesn't even have to be the lowest common denominator. You could use 12. You could use 24. You could use 48. You could use 120. 6. We're going to multiply everything by 6. Put your pencils down for a second. Look up. To show you that I'm multiplying everything by 6, a few years ago at a different high school, I saw one teacher, they did this with their students. They put a 6 there, a 6 there, a 6 there, and a 6 there. I hated that because what does that 6 look like? Looks like exponents. So don't do that. Pick up your pencils up. I'm going to multiply by 6, by 6, by 6, and by 6. And I'll do that by putting a little 6 up and in front. Write that down. Why is that so helpful? Well, now I'm going to do the numbers. This first term here is really 6 times 2 divided by 3. Oh, and attach an x. What is 6 times 2, Jordan? Divided by 3? And attach an x. This first term works out to 4x. Oh, and then I see a minus sign. Check. This second term is going to be 6 times 5 divided by 2. Jack, what's 6 times 5? Oh, okay, 30 divided by 2. Yeah, 15. I dropped my equal sign already, keeping it in line. Kirkland, the next term is going to be 6 times 1 divided by 2. Qu'est-ce que c'est? See a little immersion math for you guys. Plus. The last term is going to be 6 divided by 3. Oh, and attach an x. Nate, what's 6 divided by 3? And yeah, good. And attach an x. Nate, do you see any more fractions? In fact, not only that, I see on the left side one variable and a number, and on the right side one variable and then a number. I swear to you, I think we just turned it back into 1a. Yes? Good, solve it. I'll do it up here. Let's see if we get the same thing. By the way, often these won't work out evenly. Sometimes they will, but when there's fractions involved, Graham, it's tough to make them work out evenly. And I don't like you guys enough to put that much time into it. You know I got nice Kleenexes right over there, Jordan, in the box with the lotion and everything? The good ones? It's like a spa for your nose. Yeah, I don't like you guys enough to make my questions work out evenly, but I do like you guys enough to spend extra money on the Kleenex tissues. So there you go.
Those Kleenex tissues are expensive too.
Yeah, but they're great. Mr. Dewick, oh, by the way, how many of you got 9? Yes? Sarah, do you notice I didn't show the very last step? Did you see me write divide by 2, divide by 2? I'm good with that. If you've reached the point where you're comfortable enough on that last step that you can go straight to the answer and you get it right. Now, would I skip that last step on a quiz or on a test? No. Do I encourage you guys to take shortcuts in your homework to get really comfortable at this? Absolutely. But not on a quiz or a test. In fact, I'll be completely honest. When I'm teaching this to my grade 9s, I get good at equation solving in my head again. I could probably do that whole thing in my head showing no work. It would be some concentrating, but I could do it. Next one. Fractions? Yeah. Now, I have a rule. My rule when I'm solving an equation is this. I either want no fractions or all fractions. I don't want some fractions and not some fractions. That's confusing. I don't like that 4. How can I write it as a fraction? Over 1. Let's do that, all of us, right now. I want all fractions or I want no fractions, but I don't want half and half. There are fractions. How can I make them go away? Logan, I can multiply everything by a common denominator. What's the common denominator here? Sorry? 6 will work. By the way, so would 12. So it doesn't have to be the least common denominator, although that'll give you smaller numbers. So I'm going to go multiply by 6, by 6, by 6, and by 6. When I do that, on the first line, I'm going to get 6 times 1 divided by 3, 2, plus 6 times 3 divided by 2 with an x, divided by 2 with an x. Thank you. You back with me? Because you were not here. You back with me? That was funny. Oh, yeah. Brandon, 6 times 7 divided by 6 with an x. Yeah. In fact, you know what? You could just go 6 divided by 6 first, cancels, and just say there's a 7 left behind. Doesn't matter if you do the times and then divide or divide and then times. 7x and then 24. Rachel is bursting right now to say, hey, Mr. Dewick, I notice once again that we have one variable and a constant equals one variable and a constant. Yeah, that's our goal. Turn it into something we already know how to solve. So solve this. So solve this. Am I right? Yeah? Psst. Two more, we're done. For now. Next one. By the way, why can't I just cross multiply? Can't. Cross multiplying only works in one situation, Jordan. When you have one fraction equals one fraction. In all of these examples, how many fractions do I have on each side? One or more than one? So here, 2 fractions equals 1 fraction. Cross multiply won't work. Here, 2 fractions equals 2 fractions. Cross multiply won't work. But cross multiply, Jacob, is actually a shortcut for what we're doing here, multiplying both sides by a common denominator. It's why it works. But it only works when you have 1 fraction equals 1 fraction. Ah! No. Relax. Fractions. Okay, what's the common denominator? 3 and an 8, come on. 24. By the way, what's the easiest way to find a common denominator? Multiply everything on the bottom together. That might not get you the smallest common denominator, but you don't need the smallest one. It'll get you a common denominator, and often it'll get you the smallest one. What'd you say the common denominator was? I'm going to put a little 24 right there, little 24 right there, little 24 right there. This may be where you start to need your calculator, because the number in front of that first bracket is going to be 24 times 7 divided by 3. What is 24 times 7 divided by 3? So I'm going to get this, 56 bracket x plus 4. I'll tackle the bracket later because I'm in my felt set. I'm taking care of the fractions. And then there's a plus sign I noticed between the two fractions. The second one is going to be 24 times 3 divided by 8. I think 9. Double check me. Yes? And instead of an x attached to it, there's a 7 minus 3x in brackets attached to it. So I'll just drop it down. Equals. It's going to be 24 times 5 divided by 3. 40. Yeah? Now what? Expand the brackets. Okay, I can do this. I'll get 56x plus 4 times 56 is going to be 224. Double check me. Plus 9 times 7. 1, 2, 3, 4, 5, 6, 7. 63. Minus 27x, that equals 40. Now what? Like terms. So on the left side, how many x's do I really have? $56x, take away 27x. How many have I really got? Sorry, tell me. 29 x's? And then I have positive 224 plus 63. Positive 287. That equals 40. I doubt this will work out evenly. Now what? Minus 287. Hey, it's uglier, but I can't say that it's really tougher. I'm just having to use my calculator a little bit more. Yoink. Drop my equal sign down. The 29x drops down. Yay, that cancels. 40 minus 287, negative 247. Now what? So I think x is going to be negative 247 divided by 29. I would quickly check, does that work out evenly? No? Does it reduce? Well, 29 is prime. Nothing goes into 29 except for 29. So I'm pretty sure that ain't going to reduce at all. I would proudly put a box around that. I would say Duick must have made that one up in a hurry because it didn't work. No, those complicated equations, it's just a pain to make them work out evenly. You know what? Not everything works out evenly. Get used to it. Do you have room on the very, very back page of your notes? You do? I want to do one weird example with you right here. And it's this. We're not even going to solve it. I'm just going to get you started because it's going to show up in your homework. What if you have this? 2x plus 5 over 3 minus 4x minus 1 over 7 equals 5 over 2. Fractions. Do the Feltsad. Sorry? Okay, common denominator is going to be what? 42. 3 times 7 times 2 will work. Yeah, okay, so I would go like this. Put a little 42 there, little 42 there, little 42 there. Now here's the key, folks. Look up, all of you look up. As soon as you do that, even though we didn't write it at the beginning, you have to put brackets here. There are actually brackets there. They're implied brackets. And we're lazy. We don't write them when we have a binomial fraction, two things on top of the fraction, Kenzie, normally, but they are there. When you get the homework, you're going to get some questions that have binomial fractions, two terms on top. And when you multiply everything, you have to clue it, put brackets. Oh, and now I would say, hey, what's 42 divided by 3? What is 42 divided by 3? 14? And I drop the 2x plus 5 in brackets, minus 42 divided by 7, 6. Drop the 4x minus 1 in brackets. 42 times 5 divided by 2, 105. and then get rid of the brackets. So now I've turned it into something that I already know. But in your homework, Rachel, if you see a fraction without brackets and it's got two terms on top, there are brackets there. Just like there's invisible 1 in front of the x. It's implied. We don't bother writing it. What's your homework?